Okay, so in this lesson, we're looking at multiplying rational expressions. First, we're going to start with really just simplifying them. And so today we're going to have problems that ask us to simplify the expression, but also state the domain. So we have the steps listed here to follow. So a rational expression is any quotient, so division, fraction of two polynomials. So my numerator is a polynomial, my denominator is a polynomial. The domain of a rational expression is all real numbers except for those for which the denominator is equal to 0. So what we're going to do is we're going to start by first factoring the numerator and denominator. So what we're going to do is look at the expressions in our numerator and our denominator. Remember, in order to factor, we want it to be in standard form. And so for this numerator, I want to rewrite it in standard form. And really that's because my leading coefficient is going to change, and I can't have a negative leading coefficient, and so I can see that this negative 2x squared is negative. So when I factor this, I'm going to have to factor out that greatest common factor. So when I look at my numerator, I'm going to start there. I can factor out a negative 2. So I see that my leading coefficient's negative. Each of these coefficients are divisible by 2. So if I factor out a negative 2, negative 2x squared divided by negative 2 is going to be positive x squared. Positive 8 divided by negative 2 is negative 4. So my numerator, I can factor as factoring out a GCF of negative 2. And then I'm left with x squared minus 4. I'm going to write a new fraction because I see that I can factor x squared minus 4 again. Isn't this a difference of 2 squares? So when I have something like this, I can factor out the negative 2, but now what I'm left with is the difference of 2 perfect squares. So if I take the square root of the x squared, that means that my a value is x. And if I take the square root of the 4, that means that my b value is 2. And so the square root of 4 is 2. And so this factors as x plus 2 times x minus 2. Okay, so I can factor negative 2x squared plus 8. I've just looked at the numerator so far. I factored out a GCF of negative 2. That left me with x squared minus 4. I noticed that that was a difference of 2 squares. So it's the product of conjugates, x plus 2 times x minus 2. So I've fully factored my numerator. Now I want to factor my denominator. So when I have 3 terms, I want to do a product sum. So if I'm looking at this, my a value is 1, my b is 3, and my c is negative 10. Okay, so for this product sum, I'm going to write this over here. I'm looking for 2 numbers that multiply to 1 times negative 10. So they have a product of negative 10 and a sum of 3. So remember that my factors of 10 are 1 and 10 or 2 and 5. So in order to get a negative 10 with a positive sum, my smaller numbers would need to be negative. So I can see that negative 2 plus 5 is going to equal positive 3. So remember that when a is 1, I don't have to do grouping, and so I can just factor this to be x minus 2 times x plus 5. Okay, so I factored x squared plus 3x minus 10 to be x minus 2 times x plus 5. So now I'm done with step 1. So all that, and we're done with step 1. Step 2 asks us to find the zeros of the denominator and write the domain. So this is like what we did when we found wholes or vertical asymptotes, except our domain is going to be all real numbers except these x values. So except our x is not allowed to equal what values would make our denominator 0. So this 0 would be positive 2, and this 0 would be negative 5. So I only care about my denominator zeros. So it can't be positive 2, and it can't be negative 5. So my last step is to simplify or reduce my expression. So in order to simplify, remember that means that if I have the same factor in the numerator as the denominator, that I can reduce, that those divide to 1. So that means that I'm left with, in my numerator, a negative 2 times x plus 2. And in my denominator, all that I have is an x plus 5. So that is my answer. So I've simplified this. I get negative 2 over x plus 2 over x plus 5. Notice I'm not multiplying that negative 2 through. I'm going to leave it factored. Okay, so now we're going to simplify something else, but the procedure is staying the same. So we're going to factor our numerator and our denominator first. So if I look at this, I'm going to kind of separate this out because these are a little more complicated. So for my numerator, I need to factor x cubed plus x squared minus 4x minus 4. So remember that the number of terms tells us how we should factor. So if something has 4 terms, that means that we should divide it in half and factor by grouping. So if we look at the first group, we can factor an x squared out of my first 2 terms. So my only terms are x cubed and x squared. So if I factor out an x squared times x would make x cubed, and x squared times 1 would make x squared. So remember that when I group, I should also end up with an x plus 1 if I factor out the greatest common factor of the second set of numbers. So in order to do that, I would have to factor out negative 4. So if I factor out a negative 4 from 4x, I'm left with x. If I factor out a negative 4 from negative 4, that gives me 1. So remember that my common binomial factor is the first factor. So my first factor here is x plus 1. My second factor is my resulting GCF. So that was x squared minus 4. This I factored in the previous problem as x plus 2, x minus 2. So I need to recognize that this is a difference of 2 squares again. So my full factorization of my numerator is going to be x plus 1 times x plus 2 times x minus 2. Okay, so my numerator, I'm going to write this down here, is going to be x plus 1 times x plus 2 times x minus 2. Then I need to factor my denominator. Okay, so I factored my numerator. Now I'm going to factor my denominator. So in this one, I have 2x cubed plus 2x squared minus 12x. So there's 3 terms. So I'm going to do a product sum at some point. I want to check a GCF though first because I noticed that all these are even numbers. So I see that I can factor out a 2. It's not going to be negative 2 like it was in the last one because my leading coefficient is not negative. I also see that every term has an x, so I can take out a 2x from my expression 2x cubed plus 2x squared minus 12x. If I do that, I'm dividing everything by 2x so that this coefficient is going to go away. It's going to turn to 1. And then x cubed divided by x squared, x is x squared. I'm going to divide 2 by 2 again, so my coefficient's 1. And then my exponent's going down by 1. The last one's not going to have an x anymore because I factored it out. And then negative 12 divided by 2 is negative 6. So I have a 2x I've factored. So I know that that's going to be the first part of my denominator. So my denominator is going to have a 2x. I need to figure out what the other two factors are. I know there's 2 because this is x squared, right? That tells me there's 2 factors. So remember that because I have a 1 here and a 1 here, my A is 1, my B is 1, and my C is negative 6. So when we do our product sum, we're looking for 2 numbers that multiply to 1 times negative 6 and add to 1. So what multiplies to negative 6 and adds to 1? And so that my factors of 6 are 1 and 6, or 2 and 3. So in order to make it negative, I know one of them needs to be negative. Since my sum needs to be positive, it would need to be the smaller one, right? That would give me positive 5. If I make the 2 negative, that gives me 1. So I know these are my 2 factors. So that means that this factor is as x minus 2 and x plus 3. Okay, so this factors to 2x times x minus 2 times x plus 3 in my denominator. Our domain is always all real numbers except the numbers that will make our denominator 0. So x cannot be. Remember that when I have something like this 2x, that means that x can't be 0. If I have something that's a sum or difference, so notice there was no adding or subtracting in the 2x, that's why it was 0. If I find the 0 of this, positive 2 will make negative 2 0, and then negative 3 will make x plus 3 0. So my domain is all real numbers except 0, 2, and negative 3. So again, this worked the same way as if I was finding vertical asymptotes or holes, but I don't have to differentiate. So when we were graphing, whatever reduced was a hole. So if I think about this one, I can reduce x minus 2 with x minus 2. So in a graph, that would mean I had a hole at positive 2. In an equation like this, it's just part of that equation. So that means that my answer, what I'm left with, is x plus 1, x plus 2 in my numerator, and then 2x times x plus 3 in my denominator. So I factored my numerator and my denominator. Then I found the zeros in my denominator, so just like holes or vertical asymptotes. And then I reduced my fraction. So my resulting answer is that reduced fraction. So then what we're going to look at in example 3 is now we just have kind of more going on. And so when I'm multiplying different rational expressions together, I still need to factor everything. But now what I can do is I can reduce factors in any numerator with factors in any denominator. Okay, so in these problems, I'm not going to identify the domain just because there's a lot more work going on. So I'm just going to be factoring and reducing, and I'm going to write my answer as a single fraction in the end. Okay, so let's start. If I look at A, I have 3 fractions being multiplied together. If I start to look at these 5x, I cannot simplify 5x. I cannot factor x plus 3. Okay, so this first fraction I actually can't do anything with. The second fraction, I have some quadratic trinomials, so I'm going to have to do product sums. The second one, I just have 2 terms. Notice I can just do a GCF. So if I think about x squared plus x, can I factor an x out from each term? And so that's going to leave me with, if I divide x squared by x, x, and if I divide x by x, I get 1. So this numerator here is just x times x plus 1. I can do something similar with my denominator. So if I have 5x minus 10, 5 goes into both x and 10. So I can factor out of 5, which leaves me with x minus 2. Okay, so If I look back, didn't we already factor x squared plus x plus 6? Isn't that what we had here? We had x squared plus x plus 6. So we already did this product sum. And so that means that we can use those two factors. I'll show the work just in case if you want to have that expression there. So I'm going to highlight this guy and I'll do light blue. And then using that, I'm going to talk about my A, B, and C, right? So this one has an A value of 1, a B value of 1, and a C value of negative 6. And so we want to do a product sum so that it multiplies to negative 6 and adds to 1. And so that's where we got the 2 and the 3, where they have to be a negative 2 and a positive 3. So I'm going to rewrite that as x minus 2 times x plus 3. So remember how we talked about factoring is not going away. We have all of these methods that we need to be able to do. My last one I have to factor is x squared plus 2x plus 1. So A is 1, B is 2, C is 1. I'm going to write this one over here. So A equals 1, B equals 2, C equals 1. Remember, I multiplied those two together to get my product. So I need two numbers that multiply to 1 and add to 2. The only factors of 1 are 1 and 1. So that means that I have x plus 1 times x plus 1 as my factorization. If I had to find my domain, I would be excluding negative 3 for the first denominator, negative 1 for the second denominator, and positive 2 for the third. So don't lose that skill. We will still use it in problems. So it's important to remember that those are the excluded values. So in the previous example, I only had one fraction. So I was reducing anything from the numerator with the same thing from the denominator. Now I have multiple numerators and multiple denominators. So as long as it's in the numerator of 1 and the denominator of any, I can reduce. So x plus 3 will reduce, as will x minus 2. I also have this x plus 1, but I can only reduce it with one of the x plus 1s. Okay, so notice I've almost gotten rid of everything in my numerator. I'm going to regroup this just so that I can see it laid out. So I have a 5x times an x. So I have a 5x over 1. And then here I have a 1 over x plus 1. And then this one, all I have is an x and a 5. So I actually missed one. I can reduce the 5s. So if I reduce the 5s, those are going to go away, right? I'm going to have 1s there. And so if I multiply straight across, notice that I just have x times x. So that's going to become x squared. And then I just have x plus 1 in my denominator. So all that I'm left with is x squared over x plus 1. All that I'm left with is x squared over x plus 1. So we factor everything, and then we reduce. So if I look at B, my numerator is x squared minus 16. So two terms, perfect square, perfect square. So that's a difference of two squares. So that factors to x plus 4 times x minus 4. My denominator doesn't factor that way because it's not x squared. But remember that I want to think about it as negative x plus 9. I need it to be in standard form. So if it's negative x plus 9, then I can factor out the negative 1, my leading coefficient. I don't want to have a negative leading term. So if I factor out the negative 1, that leaves me with a positive x minus 9 in my denominator. So I factored the entire first fraction. I need to factor the second one. Both of these are trinomials where my leading coefficient is 1. So for both of these, I can just do the product sum and use the values that I determine from there. So I'm really just looking at what multiplies to negative 90 and adds to 1. Okay, so I'm looking at my factors of 90, or I'm looking up the factors of 90, and I want to check 9 times 10 makes 90. If I make the 9 negative, then that plus 10 is going to give me the positive 1. So that means that my numerator is going to factor to x minus 9 times x plus 10. Similarly, if I look at my denominator, I need numbers that multiply to 40 and add to 14. So I want two numbers that multiply to 40 and add to 14. So if I get stuck, remember I want to look up the factors of 40. 4 and 10 are going to be the two that work. So 4 times 10 makes 40. 4 plus 10 makes 14. So my factors then will be x plus 4 times x plus 10. Okay, so I've done step 1. I factored everything in my expression. And now I'm going to simplify. I'm going to reduce every factor in the numerator that has the same factor in the denominator. Notice that I can reduce the 10s. They come from the same fraction, x plus 10. But the other ones I'm going to have to cross reduce. So if I have an x minus 9 and an x minus 9. I also have an x plus 4 and an x plus 4. So notice that everything reduced except for an x minus 4 over negative 1. Okay, so if I think about that, that means that I have like a negative times x minus 4. Or if I really wanted to, I could write that as negative x plus 4, but this is the better answer. Okay, so I could distribute the negative if I really didn't like the parentheses. I wanted to write a little bit less. And so that is that expression. So remember that these domains do still apply. So like this one, I can't have x equal to 9, negative 4, negative 10. But it's not asking me to do that in this example. So know that it could for all the homework problems, that I'm still going to just take those factored. So even if it reduces, it still would be excluded from the domain. It would still make the original problem 0 in the denominator. Okay, so I know that these are relatively long, but all your factoring skills are coming in handy. So make sure that you're practicing those.